This is the next section in chapter 7. If I go by my letter labeling, it's actually 7H, and this is under complex fractions. If you want to refer to your book, it's in section 7.6. Okay, so what is a complex fraction? Basically, it's just a quotient of two rational expressions. So what this is the quotient of two rational expressions. So take for example of complex fractions would be, for example, x minus 1 over x divided by 2 plus 1 over x. Okay, so that's an example of a complex fraction. There is two methods that you can apply. So method 1 is you rewrite as a division problem. So what that means is I'm rewriting this as x minus 1 over x divided by 2 plus 1 over x. So I'm splitting this up into two problems as a division problem, and then all I have to do is follow order of operations, which require me to do what's in the parentheses first. So sharing a common denominator makes this x as the denominator, so it's going to be x is like x over 1. So if you times x to the top and bottom, it makes it x squared minus 1 for the front fraction divided by, and I do the same for the second set of fractions here, where I use a common denominator, in this case also x, and I can multiply top and bottom by x, which makes it 2x plus 1. Okay, so now that is in the division problem. Remember, in division you need to have a single fraction divided by a single fraction, which is why I have to combine the two fractions into one first, which is what this step is doing. And then in division, remember, you're supposed to flip the fraction in the back to turn it into a multiplication problem, and then you have to factor. Okay, so do your factoring, and when you're done with your factoring, you now look for factor pairs to cancel. I don't see any factor pairs, but I do see, well actually I do see one right here, x and x, and that's about it. So what my final answer is going to be is x minus 1, x plus 1, all over 2x plus 1. Okay, so this is method 1, where I use, I write it as a division problem. Now, the method 2 that I'm going to introduce to you is what we call clear the fractions. Okay, clear the fractions by multiplying each term in the numerator and denominator by the LCD. So this is the second method that I'm going to show you with, and I'm using the same problem, x minus 1 over x divided by 2 plus 1 over x, okay, but I'm using method 2. So what this method does is it multiplies all four terms at once by the LCD. So if you look at all four terms, the LCD is still x, so I'm going to choose to multiply by x, 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 and x. So you do it to every single fraction or every single term that's both in the numerator and denominator. Equivalently, you notice what I'm trying to do is to multiply the top and bottom by something. Okay, and since the number I choose to multiply is the same on both, that's really equivalent to multiplying by 1. So what happens is, in the first fraction over here, x times x is still x, so in this case it will be x squared. But in the second fraction, the denominator actually cancels with the LCD I am multiplying with, so I end up with minus 1 over, now 2 times x is 2x, but when you take the x and divide by x, it cancels, and it ends up with plus 1. So in that sense, as the name implies, it clears the fraction. Okay, so all of a sudden it kind of cleans things up. And then remember to factor, okay, and then look to see if there's a pair. If there isn't, you're done. So comparatively, I think the second method is a little faster, okay, but you can choose to use either methods. Okay, let's look at another example. Say 1 over a minus 1 over b all over a over b minus b over a. Let's try that. Okay, so if you want to use method 1, what it does is it rewrites this problem into a division problem. Okay, and then what you do is you share a common denominator. In this case is ab. And so the first fraction I have to multiply by b, which makes it a b, and the second fraction I have to multiply by a. So you kind of have to figure this out like that. Okay, and then in the second set of pairs of rational expressions, the denominator is also ab. So here I have to multiply by a, which makes it a squared. In the back I have to multiply by b, which makes it b squared. So now I have b minus a over ab, and I need to turn this into multiplication, and so I flip ab on the top and the a squared minus b squared at the bottom. So before I start canceling, let me do my factoring for everybody, and really the only one I can factor is the a squared minus b squared, so it's a and a, b and b, 1 plus and 1 minus. Okay, so now a and a cancels, okay, and then b and b cancels, okay, and then the b minus a that you see here actually does cancel with the a minus b, except that it becomes a negative 1. So the final answer to this question is going to be negative, and then 1 over, and the denominator is a plus b. Okay, so that would be the answer. Now if I want to use this problem and work with method 2, okay, so let me show you using method 2. What I would do is 1 over a minus 1 over b divided by a over b minus b over a. So I'm going to attack all 4 fractions at once, or all 4 terms at once. The LCD for all 4 of them is going to be ab. So I'm going to multiply by ab, 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 and ab. Now remember, when you say ab, it's really ab over 1. So the ab really belongs to the numerator. So if you like, you can write it like that. Okay, so that explains why the a's cancel, okay, but you don't multiply to the denominator. So what you end up with is just b, and on the second fraction, the b's cancel, leaving me with a. The fraction on the left, in the denominator, the b's cancel, leaving me with a squared, and minus, and the a's cancel, leaving me with b squared. Okay, so in that sense, that's what I have. And then I have to factor the numerator, which I can't do anything, but the denominator, I can break it down to a and a, b and b, 1 plus and 1 minus. So once I have it factored, I'm looking for factor pairs, and those are one pair except the opposites, and there you have it. That's the answer. Okay, let me show you one more example. Say if I have x squared minus 16 over 1 over 4 minus 1 over x. Let's say, okay, let's try this one. So if I use method 1, what I'll do is I'll write x squared minus 16 in the front, divided by 1 over 4 minus 1 over x. So x squared minus 16, if there's not much I need to do about that, because it's really like over 1, right? You could try to factor it though. The LCD in this case is 4x, right? And if you multiply by x to the front and multiply by 4 to the back, you end up with that. So this front fraction, I'm going to factor it as x minus 4x plus 4 over 1. I'm turning this into multiplication, and 4x over x minus 4. So look for factor pairs to cancel, and we're done. And so the answer is 4x and x plus 4. Okay, so that's using method 1. So let me show you using method 2. So using method 2, let's rewrite the problem again. So the problem was x squared minus 16 over 1 over 4 minus 1 over x. Okay, so remember, x squared really means x squared over 1, just a 16 over 1. So in this whole problem, my LCD is still 4x. Okay, so what I have is going to be 4x multiplied to x squared minus 16, and I'm going to take 4x to multiply by 1 over 4 minus 1 over x, and I'm going to multiply by 4x as well. So in the top, I'm just going to factor it right away to make it x plus 4 and x minus 4. In the denominator, the 4's cancel, leaving me with x, and the second fraction, the x's cancel, leaving me with 4. Okay, so you notice they cancel, and then you have your answer. So it's up to you which method you prefer, but whichever method you choose, I think you should just stick to it and just keep practicing on it. Okay, so let me write down some problems for you to try, and these problems are found in 7.6. You can find them on page 334, and the numbers are 31, 33, 35, 37, 39.